My video froze for some reason while we were working out one of the practice problems, so I'm re-recording. Anyway, the question was, what volume would 12 grams of helium occupy at 20 degrees Celsius with a pressure of 380 millimeters of mercury? So wanted here, it asks what volume. So I'm going to put wanted as V, and then given on this side, I was given 12 grams of helium gas, 12 grams of helium. I hope you guys can see this. I don't know if it's clear. But anyway, 12 grams of helium and a temperature of 20 degrees Celsius and a pressure of 380 millimeters of mercury. Okay. So I want the volume, and I know that this is just a PV equals nRT plug and chug type problem, but the most important thing for me right now is just so that you guys try to practice solving for the variable first. I want to just divide both sides by P before I plug in any numbers. So now I wind up with V equals nRT divided by P. This is going to be the equation that I use. And now if you look at what I've been given, and then if you look at the variables here, you're going to find some problems. Like for example, I told you that the constant R, I'm going to write it to the side over here, R is 0.82 liters times ATM divided by moles times Kelvin. Okay, sorry, it's kind of bumping in here. So this is my little R constant, right? Now, if I look at my R constant that I have, and I have, ATMs right here for units of pressure, I'll look at the given units of pressure, and it's in millimeters of mercury. So I know that I'm going to want to convert to ATM, and I do that by taking the pressure I was given and multiplying it by 1 atmosphere over 760 millimeters of mercury. That's my conversion factor. So the step one is I'm going to get my pressure in units of atmospheres. Okay, that way my ATMs are going to cancel. The second thing I'm noticing is my value for R is in Kelvin, and the temperature here was given to me in degrees Celsius. So what I'm going to want to do now is take my degrees Celsius, and I want to actually add to it 273. That will convert it to Kelvin, okay? So if I add 20 plus 273, I get 293 Kelvin. And then the last problem I'm having is volume is equal to the number of moles, okay? But I was given grams of helium. So I'm going to actually have to look up the molar mass of helium on my periodic table, and I'm going to find that in 1 mole of helium, I have 4 grams. Okay, so my grams of helium are going to cancel, and I'll be left with 3 moles of helium. And now I'm actually ready to start plugging in these numbers. I don't know if this looks really confusing. I'll try to close it up, hold it up closer to the camera. But basically, the first step that I did to solve this problem was I just created a little chart for myself. What is it that I want and what is it I'm given? Then I went ahead and using my ideal gas law equation, I solved for volume because that's what I want. And then I just check to make sure that everything I was given was in the appropriate units. And basically every single thing I was given was not in the appropriate units, so I converted to the units I wanted everything to be in. I wanted moles, I wanted Kelvin, and I wanted ATM. Okay? So the last step now is just a plug and chug. Volume is equal to 3 moles of helium, okay, times this constant, right? And you will be given this constant on the AP exam. I think I accidentally said memorize it, and then I checked, and I was wrong. So anyway, 0.082 liters times ATM divided by mole times Kelvin. Okay. What What else am I missing? Temperature. Now, okay, so I got my moles in my equation. I plugged in R. Now I'm just missing T for temperature. So I look over here and it's 293 Kelvin. So times 293, 10, that looks like a 9, K. And now the really cool thing is I can already see that my moles of helium are canceling with moles at the bottom and my kelvins are canceling. So now, in order to finish, I divide everything by P, which is what I'm going to do, divide everything by, and I don't have a calculator, so I'm sure you can work this out, whatever 380 divided by 760 is. I'm going to put whatever my pressure is in ATM, and that will make actually my ATMs cancel. So I'm just left with volume equals 3 times 0.082 liters times 293 divided by whatever number this is. And I wind up with an answer in liters. And that would be how I work out this problem. I'll do another problem in a second, but I'm going to have to turn off this video because YouTube is not letting me upload except for really tiny short videos. So I'm going to follow this up with another one. Just hold on.